Out there, 2.5 million light-years away, our cosmic neighbor, the Andromeda Galaxy hides secrets older than time itself. Picture a sprawling city of stars, not just in its glittering disk, but wrapped in an invisible cloak of mystery, its halo. This vast, ghostly region stretches far beyond the galaxy's bright arms, a graveyard of ancient stars, dark matter, and something else, something unexpected. Astronomers have begun spotting bizarre objects lurking in Andromeda's halo, structures that defy explanation, remnants of cosmic violence, and clues to the galaxy's turbulent past. These aren't just random specks of light, they're cosmic oddities, each with a story to tell. Galactic halos are like the fingerprint of a galaxy's history, and Andromeda's is especially strange. While most halos are quiet and diffuse, Andromeda's is teeming with peculiarities: streams of stars torn from cannibalized galaxies, rogue black holes, and perhaps even dark matter in forms we've never seen. What makes these discoveries so thrilling isn't just their strangeness, but what they reveal about how galaxies grow, collide, and evolve over billions of years. Andromeda isn't just a static island of stars, it's a living, breathing entity still shaping its destiny. So what are these mysterious objects? Some could be the corpses of dwarf galaxies, devoured long ago by Andromeda's gravity. Others might be the scars of ancient collisions, or even entirely new classes of celestial phenomena we've yet to understand. One thing's for sure, each discovery peels back another layer of the universe's grand narrative. And that's why we're diving deep into the heart of Andromeda's halo today, to uncover 30 of the strangest, most enigmatic objects ever found there. From stellar ghosts to cosmic anomalies that challenge everything we know, this journey will take us to the edge of our understanding and beyond. Strap in. The universe is about to get a whole lot weirder. The first strange object lurking in Andromeda's halo isn't something you can see, it's something you feel. Hidden in the galaxy's outer reaches, astronomers have detected a mysterious clump of dark matter so dense it bends the very fabric of space around it. Imagine an invisible boulder dropped into a cosmic pond, warping the light from distant stars like a funhouse mirror. This bizarre phenomenon, called gravitational lensing, is how scientists first spotted the anomaly. But what makes this clump so puzzling isn't just its presence, it's the way it defies our expectations. Current theories suggest dark matter should be spread smoothly through a galaxy's halo, like fog settling over a landscape. Yet here, it's clumped together in a tight, massive knot, as if some unseen force crammed it into a smaller space than nature should allow. Simulations struggle to explain how such a dense concentration could exist without dispersing over time. Some researchers wonder if it's the remnant of a smaller galaxy, shredded by Andromeda's gravity but leaving its dark matter core intact. Others speculate it could be evidence of exotic dark matter particles interacting in ways we've never predicted. The implications are staggering. If dark matter can clump this way, it might rewrite our understanding of how galaxies form, or even hint at entirely new physics lurking in the shadows of the cosmos. Every flicker of distorted starlight through this lens is a whisper from the universe's hidden rulebook, and Andromeda's halo is holding the pages wide open. Now, let's turn our attention to an eerie river of stars winding its way through Andromeda's halo, a colossal stellar stream so vast it could wrap around our Milky Way multiple times. This isn't just a random scattering of stars, it's a cosmic crime scene, the shredded remains of a dwarf galaxy torn apart by Andromeda's gravity billions of years ago. Picture a glittering ribbon stretching over 200,000 light-years, its stars moving in eerie unison like a school of fish caught in an invisible current. What makes this stream so fascinating isn't just its size, but its story. By analyzing the motion and chemistry of these stars, astronomers have pieced together a violent past. The stars in this stream are older and metal-poor, a telltale sign they belong to a small, ancient galaxy that wandered too close to Andromeda's gravitational pull. Over eons, tidal forces stretched and twisted the dwarf galaxy like taffy, until all that remained was this luminous trail, a ghostly echo of a long-dead cosmic neighbor. But here's where it gets even stranger. The stream isn't smooth. It's clumpy, with dense knots of stars and gaps where you'd expect a steady flow. This suggests the dwarf galaxy didn't go down without a fight. Perhaps it had its own smaller companions, or maybe it orbited Andromeda for billions of years before finally unraveling, leaving behind these stellar fingerprints. Telescopic images reveal the stream's faint glow, while artist renditions bring its turbulent history to life, a vivid reminder that galaxies aren't just static collections of stars but dynamic, ever-changing beasts. This discovery challenges our assumptions about how galaxies grow. We used to think mergers were clean, orderly affairs, but Andromeda's halo tells a different story, one of chaos, destruction, and rebirth. Every star in that stream is a silent witness to the universe's relentless dance of creation and destruction. And if we listen closely, they might just reveal secrets about our own galaxy's future, because one day the Milky Way and Andromeda will collide, and streams like this could be all that remain of us. Deep in the swirling outskirts of Andromeda's halo, astronomers have stumbled upon something that shouldn't be there, a pulsing radio signal so bizarre, it defies every known cosmic radio station. Unlike the steady hum of a pulsar or the explosive crackle of a supernova, this signal fires off in unpredictable bursts, vanishing for months before suddenly crackling back to life. The strangest part, when scientists point optical telescopes toward the source, they find nothing, no star, no remnant, just empty space whispering radio waves into the void. This unidentified radio source, dubbed Andromeda Echo by researchers, has sparked debates across astronomy. One leading theory suggests it could be an exotic type of neutron star we've never encountered, spinning so fast its magnetic field whips up radio storms unlike anything in our catalogue of celestial objects. But there's a problem. Neutron stars leave X-ray signatures, and this source stays stubbornly silent outside radio wavelengths. Other scientists propose it might be the death cry of a black hole consuming a stray star, except the signal's repeating pattern doesn't match the chaotic fireworks of such events. Then there's the wild-card explanation. Could this be technosignature, the faint signature of an advanced civilization? While most astronomers consider this unlikely, the absence of natural explanations keeps the question alive. Radio telescope arrays have captured the signal's fingerprint, a series of sharp, millisecond bursts stacked like cryptic Morse code against the static of deep space. Each detection sends researchers scrambling to compare it with known phenomena, only to find it matches nothing in our databases. What makes Andromeda Echo truly unsettling is its location. Most cosmic radio sources cluster near star-forming regions or galactic cores, but this one drifts alone in the halo's sparse outskirts, far from the densely packed stellar neighborhoods where such activity usually thrives. It's as if someone left a radio transmitter running in a cosmic desert, broadcasting to no one. Could it be a relic from Andromeda's violent youth, a fossilized scream from some long-forgotten cataclysm? Or is it something entirely new, a cosmic oddity waiting to rewrite our textbooks? Until we solve the riddle, one thing is certain: the universe loves a good mystery, and Andromeda's halo is its favorite hiding place. Nestled within the haze of Andromeda's halo, there's a celestial relic so faint it was almost missed entirely, a ghostly gathering of stars known as a globular cluster, but unlike any other we've seen. This ancient structure, catalogued as Halo 1, glows with the pale light of stars born when the universe was still in its infancy. Most globular clusters are dazzling balls of hundreds of thousands of stars packed tight like glittering beehives. But this one, it's sparse, dim, and eerily quiet, as if the stars themselves are whispering secrets from a time before galaxies took shape. What sets Halo 1 apart isn't just its age, estimated at over 13 billion years, but its bizarre chemistry. When astronomers analyzed its light, they found something startling. These stars contain almost no heavy elements. In cosmic terms, that's like finding a village untouched by modern technology, frozen in the Stone Age. Typical globular clusters have traces of metals forged in supernova explosions, but Halo 1 stars are pristine, composed almost entirely of hydrogen and helium, the raw ingredients of the Big Bang. This makes it a living fossil, a time capsule from an era when the first stars were just beginning to cook heavier elements in their cores. The discovery challenges what we thought we knew about how globular clusters form. Most of these clusters, including those orbiting the Milky Way, are thought to have been born in the chaotic mergers of gas-rich early galaxies. But Halo 1's extreme poverty of metals suggests a different origin. Perhaps it formed in near isolation, from a collapsing cloud of primordial gas untouched by later cosmic pollution. Its stars burn so faintly that without ultra-sensitive telescopes, we'd never have spotted them against the backdrop of Andromeda's halo. And here's where it gets even more intriguing. Halo 1 isn't alone. A handful of similar ghostly clusters have been spotted in other galaxies, hinting that these relics might be more common than we realized. Each one is a puzzle piece in understanding how the earliest structures in the universe took shape. If typical globular clusters are like bustling cities, Halo 1 is a deserted ruin, its silent stars holding clues to a time when the cosmos was young, dark, and utterly unrecognizable. Studying clusters like this is like reading the universe's first diary. Their faint light carries the fingerprints of conditions we can't recreate. No simulation or lab experiment can take us back to that primordial dawn. Yet here they are, drifting in Andromeda's halo, waiting to be decoded. Every observation peels back another layer, revealing just how little we truly know about the chaos and beauty of the universe's beginnings. Now we come to one of the most thrilling fugitives in Andromeda's halo, a star blasting through space at speeds that defy logic. This cosmic speedster, known as a hypervelocity star, isn't just moving fast, it's racing through the galaxy's outskirts at over 1 million miles per hour, fast enough to cross the continental United States in less than 10 seconds. How does a star reach such insane velocities? The answer lies in one of the universe's most violent events, a gravitational slingshot orchestrated by nature's ultimate escape artist, a supermassive black hole. When astronomers first tracked this star's trajectory, they noticed something peculiar. Unlike most stars in Andromeda's halo, which drift lazily in vast orbits, this one cuts through space like a bullet, its path tracing a straight line from the galactic center. That's the smoking gun. Simulations suggest it was once part of a binary star system that wandered too close to the black hole lurking at Andromeda's heart. In a cosmic game of gravitational tug-of-war, one star was captured by the black hole's pull, while its partner was flung outward at unimaginable speed like a stone from a slingshot carrying enough kinetic energy to escape the galaxy entirely. But here's what makes this star truly special, its composition. Spectroscopy reveals it's richer in heavy elements than typical halo stars, a clue that it was born closer to Andromeda's crowded core, where generations of supernova have enriched the cosmic environment. As it screams through the halo, it leaves behind a shimmering wake of ionized gas, a fleeting trail that telescopes can barely detect. Artists' renditions bring this journey to life, showing the star as a brilliant streak against the haze of distant suns, its light subtly blue-shifted as it hurtles toward intergalactic space. Where is it headed? Barring an unlikely collision, this star's fate is isolation. In a few 100 million years, it will breach Andromeda's halo entirely, becoming a lone wanderer in the abyss between galaxies. There, in the freezing void, it will burn quietly for billions of years, far from any planetary system that might bask in its light. Yet its story doesn't end there. Hypervelocity stars like this are cosmic messengers. By studying their speed and trajectory, astronomers can map the hidden gravitational landscape of galaxies, including the invisible pull of dark matter that shapes their path. This star isn't just a runaway, it's a testament to the sheer chaos lurking in what seems like a calm, orderly universe. Every measurement of its breakneck speed peels back another layer of Andromeda's violent history, proof that even in the quietest corners of the cosmos, celestial drama is always unfolding. Among the most mesmerizing illusions in Andromeda's halo are two quasars that shouldn't appear twice, yet thanks to the galaxy's invisible warping of spacetime, their light arrives at Earth as perfect mirrored duplicates. These celestial doppelgangers, catalogued as Objects 6 and 7, aren't actually twins at all. They're single, ultra-bright galactic cores billions of light-years behind Andromeda, their images duplicated by the immense gravity of the halo's dark matter acting like a cosmic magnifying glass. Gravitational lensing, the phenomenon behind this illusion, occurs when massive objects bend the fabric of space so severely that light traveling past them follows the curve, like a marble rolling along a warped tablecloth. Most lensed quasars appear as arcs or smeared crescents, but this pair is special. Hubble's sharp eye captured them as near-perfect mirror images, crisp and symmetrical, because they sit at just the right angle behind a particularly dense knot of Andromeda's halo. The alignment is so precise that astronomers can actually calculate the mass of the invisible matter causing the distortion by measuring the distance between the duplicates. What makes these quasars rare isn't just their clarity, but their story. Quasars themselves are unimaginably powerful, the luminous hearts of distant galaxies where supermassive black holes devour matter, blazing brighter than 1 trillion suns. Normally, spotting one through Andromeda's halo would be like trying to see a candle through a foggy window. But the halo's lensing effect doesn't just distort their light, it amplifies it, turning faint specks into observable beacons. Side by side, Hubble images reveal the surreal sight, two identical points of blue-white light separated by a hair's breadth in the sky, though one is actually a time-delayed echo of the other. Here's the twist: the light forming each image took slightly different paths around the lens, meaning one image is a snapshot of the quasar thousands of years before the other. If the quasar flickers, astronomers see the change in one image before it appears in its twin, creating a natural cosmic time machine. By studying these delays, researchers can map the distribution of dark matter in Andromeda's halo with unprecedented precision, turning an optical illusion into a tool for probing the invisible scaffolding of the universe. Objects 6 and 7 aren't just curiosities. They're proof that even the most distant corners of the cosmos can be magnified and brought into focus by the silent, unseen forces weaving through space. Every duplicated photon carries a message about the quasar's violent heart, about the halo's hidden structure, and ultimately about the strange, warped mirror that gravity holds up to the universe. Drifting silently through Andromeda's halo, there's a cloud of gas so ancient it remembers a time before stars existed, a cosmic fossil floating unchanged for over 13 billion years. Unlike the metal-rich nebulas where new stars are born today, this primordial cloud contains almost no heavy elements, just hydrogen and helium left untouched since the Big Bang. Astronomers call these relics metal-poor clouds, but that label doesn't capture their true rarity. Finding one is like discovering a perfectly preserved ice bubble from Earth's earliest atmosphere, a pocket of the universe exactly as it was before the first starlight illuminated the cosmos. How did this cloud survive intact while others were forged into stars and planets? The answer lies in its isolation. Nestled in the sparse outskirts of Andromeda's halo, far from the galaxy's turbulent disk, it avoided the shock waves of supernova and the gravitational disturbances that typically trigger star formation. Hubble's ultraviolet sensors revealed its ghostly outline not by the glow of excited gas, but by the way it dims the light of background stars as they shine through it, like tracing fog by the streetlights it obscures. Spectroscopic analysis confirmed its pristine state, less than 1% the metal content of our Sun, making it one of the most chemically primitive objects ever detected in a galactic halo. This cloud challenges our understanding of galaxy growth. Standard models suggest halos should be thoroughly polluted by metals from generations of dying stars, yet here sits a pocket of untouched primordial gas. Some theorists propose it might be a leftover building block, a surviving fragment of the cold gas streams that funneled material into young Andromeda during its formation. Others wonder if it was flung outward during an ancient galactic collision, preserved like a bubble in cosmic amber. Whatever its origin, its existence proves that the universe hasn't erased all traces of its infancy if we know where to look. The implications stretch beyond Andromeda. Similar clouds in the Milky Way's halo could hold clues to how our own galaxy assembled. Their chemistry acts as a time capsule, preserving the exact conditions before stellar nucleosynthesis began peppering the cosmos with heavier elements. Some researchers even speculate these clouds might still collapse to form stars one day, creating a new generation of metal-free stars unlike any seen since the universe's first few 100 million years. For now, this silent witness floats undisturbed, its atoms unchanged since the dawn of time, a reminder that the universe keeps its oldest secrets hidden in plain sight, waiting for us to decipher their whispers. Tucked away in the farthest reaches of Andromeda's halo, something invisible is making its presence known, not by what it emits but by what it tears apart. Astronomers have pieced together the trail of a lone wanderer, an intermediate mass black hole roughly 10,000 times heavier than our Sun, drifting through the darkness like a cosmic phantom. This isn't the supermassive monster anchoring Andromeda's center, nor is it the small stellar remnants scattered through the galaxy. It's something in between, a rare and elusive class of black hole that shouldn't be alone, yet here it is, untethered from any star cluster or galaxy, leaving only gravitational breadcrumbs in its wake. The first clue came from an otherwise ordinary star in the halo. Observations showed it was accelerating erratically, its light stretching and compressing as if tugged by an unseen force. Spectroscopy revealed the telltale signature of a star being gravitationally kicked. Its motion couldn't be explained by the smooth pull of Andromeda's overall mass. Then came the smoking gun. Archival Hubble images caught a flicker of ultraviolet light near the star's location, a brief flare consistent with a black hole's accretion disk igniting as it shredded a passing gas cloud. The flare lasted just days before vanishing, but it was enough to triangulate the culprit's position and velocity. What makes this discovery so groundbreaking is the black hole's isolation. Intermediate mass black holes are thought to form in dense environments like globular clusters, where repeated stellar collisions can create them. Yet this one floats free, untethered from any visible structure. One theory suggests it was ejected during a galactic merger, slingshotted out by gravitational interactions with larger black holes. Another proposes it's the stripped core of a dwarf galaxy Andromeda consumed long ago, its outer stars scattered while the black hole remained, drifting like a ghost ship in the halo's currents. Detecting such objects is like searching for invisible ink under dim light. Without nearby material to feed on, they emit no radiation. Their gravity only betrays them when they distort the motion of passing stars or ignite fleeting flares from chance encounters with gas. Yet their existence could solve cosmic mysteries like how supermassive black holes grow so quickly in the early universe. If halos are littered with these intermediate seeds, they might be the missing link in galaxy formation. Every wobble of a star, every flicker of light in the void adds another piece to the puzzle. This rogue black hole isn't just drifting, It's a silent witness to the violent processes that shape galaxies, a reminder that even in the emptiest corners of the cosmos, gravity's invisible hand is always at work. Amid the sparse sea of stars in Andromeda's halo, there's a glowing cosmic soap bubble suspended in the darkness, a planetary nebula with no planetary system left to call home. Most of these beautiful, short-lived structures form when dying stars puff off their outer layers, creating intricate veils of ionized gas lit from within by the stellar ember at their core. But this one, catalogued as Object 10, drifts completely untethered, an orphaned nebula flung into the emptiness of the halo, its parent star nowhere to be found. Hubble's sharp eye captured the nebula's delicate structure, a perfect sphere of oxygen and nitrogen glowing green-blue against the black, with filaments of hydrogen curling through it like smoke trapped in glass. Normally, a planetary nebula's chemistry acts as a fingerprint, revealing details about the star that birthed it, but spectroscopic analysis of this object left astronomers stunned. The gas is rich in rare isotopes like neon-3, a signature suggesting the original star was far more massive than typical nebula progenitors, likely part of a binary system that met a violent end. The prevailing theory, a gravitational showdown, ejected both the nebula and its star in opposite directions. When one star in a binary pair explodes as a supernova, the sudden loss of mass can send the surviving companion and any surrounding material hurtling outward like a stone from a slingshot. In this case, the shockwave from the explosion may have ripped away the dying star's outer layers prematurely, flinging the nebula into the halo while the white dwarf remnant now races unseen through intergalactic space. This orphaned bubble isn't just a pretty anomaly, it's a tracer bullet illuminating the halo's invisible forces. The nebula's motion shows it's caught in one of Andromeda's vast, slow-moving currents of dark matter, its path subtly deflected by clumps of unseen mass. By tracking its drift, astronomers are essentially using the nebula as a probe, mapping the gravitational undercurrents that shape the halo's structure. Time-lapse observations spanning years reveal its gradual distortion as the faint pressure of intergalactic wind begins to stretch its once perfect symmetry into a teardrop. What makes this object particularly poetic is its transience. Planetary nebulae typically last only tens of thousands of years before dispersing, a blink in cosmic time. This one's isolation means there are no nearby stars to illuminate it once its central light fades. Within millennia, its glow will dim, its gases will scatter into the halo's void, and all evidence of its dramatic ejection will vanish. For now, though, it floats as a silent testament to the chaos hidden in Andromeda's past, a luminous echo of a stellar breakup that occurred before human civilization began. Every wavelength of its light carries clues not just about its own tragic history, but about the dynamic, ever-changing ecosystem of the galactic halo it now calls home. Scattered across Andromeda's halo like breadcrumbs from a cosmic crime scene lies the remains of a dwarf galaxy that dared to wander too close, a once proud island of stars now reduced to a shimmering debris field stretched across thousands of light years. This ghostly structure, catalogued as Object 11, isn't just another stream of stars, it's a forensic snapshot of galactic cannibalism in progress, with each stellar cluster and gas filament telling a different chapter of its violent unraveling. Telescope surveys first spotted this disruption as an unusual concentration of red giant stars moving in sync through the halo's sparse outskirts, stars too old and metal-poor to belong to Andromeda itself. Advanced spectroscopy revealed their true origin. They were the survivors of a small galaxy roughly 1/100th the mass of the Milky Way, caught in Andromeda's gravitational jaws between 7 and 10 billion years ago. Like detectives reconstructing a shredded document, astronomers have pieced together its original structure by analyzing the chemical fingerprints and trajectories of its scattered stars. The galaxy likely had a classic discoid shape before the encounter, with a compact core now identifiable as a denser knot of stars clinging together against the tidal onslaught. The destruction didn't happen all at once. Computer simulations show the dwarf galaxy first orbited Andromeda for billions of years, each pass stripping away more stars in a process called tidal shredding. Imagine a ball of wet sand tossed into a spinning fan. Initial encounters loosened the outer layers, while later passes ripped apart the core, stretching the stars into long, looping tendrils now frozen in time. Hubble's deep field images capture this drama in exquisite detail. Some streams still trace graceful arcs, the signature of early disruption, while others form chaotic plumes where the galaxy's central regions finally disintegrated. What makes this debris field particularly fascinating is its asymmetry. Unlike neat, ring-like disruptions seen around other galaxies, Andromeda's victim left behind a lopsided trail, evidence that it didn't just collide with Andromeda's smooth halo, but also plowed through clumps of unseen dark matter. The uneven distribution of stars acts like a sonar map, revealing pockets of higher gravity where dark matter gathered to wrench the dwarf galaxy apart more violently in certain directions. Some stellar streams even show gaps, as if entire clusters were yanked away by particularly dense dark matter subhalos lurking invisibly in the wreckage. But the real treasure lies in the dwarf's surviving globular clusters, tightly bound families of stars that resisted tidal disruption. 7 of these clusters still orbit together in the debris field, their shared motion betraying their common origin. By measuring their metallicity, the abundance of elements heavier than hydrogen and helium, astronomers have uncovered surprising diversity. Some clusters are metal-rich, suggesting they formed deep in the dwarf galaxy's star-forming heart, while others are pristine relics from the early universe. This mix implies the original galaxy had a complex history of mergers before its fatal encounter with Andromeda, making it not just a victim but a cannibal in its own right. The timeline of destruction is written in the star's orbits. Stars torn away earliest now drift farthest from the main debris field, forming a faint envelope around the more recent wreckage. By comparing their positions with cosmological simulations, researchers estimate the final dissolution occurred roughly 4 billion years ago, around the same time Earth's continents were forming. Radio telescopes have even detected faint hydrogen gas lingering along the streams, the last traces of the dwarf galaxy's interstellar medium evaporating into Andromeda's halo like breath on a cold morning. This cosmic autopsy reveals more than just one galaxy's fate. The debris field acts as a scale model for Andromeda's entire growth history. Every stream contributes to the halo's lumpy structure, proving that galaxies aren't born massive. They grow by devouring smaller neighbors in a cycle as old as the universe itself. And there's a sobering postscript. The Milky Way hosts similar stellar streams, and in 5 billion years, when our galaxy collides with Andromeda, these ruins will merge two sets of galactic wreckage, tangling together in a silent testament to the violence that built the cosmos. For now, the scattered stars of Object 11 drift like confetti after a parade, their motion still echoing the moment their home galaxy met its end. Hidden in the faint glow of Andromeda's halo, there's an enigma that emits no visible light, only a whisper of X-rays, diffused across a region wider than our entire Milky Way. This bizarre feature, officially dubbed Object 12, isn't tied to any star, black hole, or supernova remnant. Instead, it hangs in space like a cosmic mirage, a vast, glowing blob of high-energy radiation with no obvious engine powering it. When X-ray telescopes first mapped this region, astronomers expected to pinpoint a compact source, a pulsar perhaps, or a cluster of neutron stars. Instead, they found something far stranger, energy spread so evenly, it's as if the very fabric of the halo is humming at X-ray frequencies. Theories about this phantom glow range from the mundane to the revolutionary. One leading hypothesis suggests it could be the collective emission of countless white dwarfs, dead stars too faint to see individually, but whose combined X-ray output might create this diffuse haze. Yet when researchers tallied up the expected number of white dwarfs in the halo, the math fell short. The glow is too bright, too widespread. Another idea points to superheated gas trapped in Andromeda's gravitational embrace, but here, too, there's a problem. Gas that hot should have long since cooled or collapsed into denser structures unless some unseen force is constantly reheating it. Then there's the more daring possibility: dark matter annihilation. Some models predict that when hypothetical dark matter particles collide, they could produce X-rays as they decay. If true, this blob might be our first glimpse of dark matter's hidden interactions, a radioactive signature etched across the halo. The challenge: no one knows exactly what dark matter is made of, or if it even decays at all. Detectors on Earth have spent decades searching for such signals, but here in Andromeda's halo, the evidence is tantalizingly indirect. Recent observations have added another layer of intrigue. The X-ray blob isn't perfectly smooth. It has subtle ripples like heat distortion over a desert highway. Some researchers think these fluctuations might trace the paths of ancient cosmic collisions, shockwaves from dwarf galaxies plunging through Andromeda's halo millions of years ago, stirring the hot gas like a spoon in soup. Others speculate they could be evidence of magnetic fields threading through the halo, shaping the X-rays into invisible patterns. What makes this mystery so compelling isn't just the unknown source of the X-rays, but what it reveals about the halo's hidden dynamics. Normally, we study galaxies by their starlight, but Object 12 forces us to reckon with the unseen forces that might govern their evolution. Every flicker of high-energy light is a clue, a piece of a puzzle that could rewrite our understanding of how galaxies live, breathe, and interact with the dark cosmos around them. Until we solve it, this ghostly glow remains a reminder. Sometimes the universe's most profound secrets don't shout. They simmer quietly in the background, waiting for us to notice. At the very edge of Andromeda's halo, a cosmic alarm clock keeps going off, a repeating fast radio burst, or FRB, that crackles to life at unpredictable intervals, blasting out more energy in a millisecond than our sun does in 3 days. This isn't just another FRB. Most of these mysterious signals flash once and vanish forever. This one, catalogued as Object 13, is a repeater, firing off multiple bursts over years, each one a fleeting but incredibly powerful pulse of radio waves that telescopes scramble to catch before they fade into silence. The strangest part, it's not coming from deep inside Andromeda's star-filled disk, but from the sparse, lonely outskirts of its halo, a place where such energetic phenomena shouldn't exist. To understand why this repeater is so puzzling, you have to know how bizarre FRBs already are. Most originate billions of light years away, likely from catastrophic events like neutron star collisions or magnetars, highly magnetic stellar corpses snapping under unimaginable strain. Their brevity and distance make them nearly impossible to trace, but Object 13 is different. Its bursts are closer, brighter, and crucially repeating, a pattern that defies the one-and-done nature of typical FRBs. When astronomers traced its location to Andromeda's halo, the discovery sent shockwaves through astrophysics. This isn't just a mystery, it's a mystery parked right in our cosmic backyard. The leading theory points to an exotic kind of magnetar, a neutron star with a magnetic field so strong it could strip the data from a credit card halfway across the galaxy. Some magnetars are known to produce FRBs when their crusts crack under magnetic pressure, sending shockwaves through space. But for a magnetar to be alone in the halo, untethered to any star cluster or supernova remnant, raises questions. How did it get there? One possibility is that it was ejected from Andromeda's disk during a violent interaction, perhaps a close encounter with a black hole that flung it into the void like a cosmic slingshot. There's a wilder alternative, though. What if this isn't a magnetar at all? Some scientists speculate that repeating FRBs could be signs of advanced technology, alien beacons, or propulsion systems. While most astronomers consider this unlikely, the absence of a visible host object keeps the door slightly open. The truth is, we've never seen an FRB repeater in a galactic halo before, so all bets are off. Every new burst from Object 13 carries a fingerprint subtle variations in frequency and polarization that might hold clues. Recent observations show its bursts are slightly twisted, a phenomenon called Faraday rotation, suggesting they're passing through a weak magnetic field on their way to us. What makes this repeater truly extraordinary is its isolation. FRBs usually come from regions bustling with star formation or the chaotic hearts of galaxies. This one drifts in near emptiness, as if whatever's producing it doesn't need the usual cosmic fuel. Some researchers wonder if it's the last survivor of a destroyed dwarf galaxy, its host long since assimilated into Andromeda's halo. Others propose it could be a primordial magnetar, a relic from the universe's first stellar generation, lurking undisturbed for billions of years. Each burst is a breadcrumb leading us closer to an answer. Radio telescopes now monitor Andromeda's halo constantly, waiting for the next signal. When it comes, it could rewrite what we know about these enigmatic cosmic sirens, or deepen the mystery even further. One thing's certain, in the quiet expanse of Andromeda's halo, something extraordinary is talking. We just have to learn how to listen. Tucked away in Andromeda's halo, far from the galaxy's star-forming heart, there's a cosmic contradiction, a brilliant splash of blue stars burning with youthful intensity against the ancient backdrop of the halo's rust-colored giants. This cluster, nicknamed the blue blob, shouldn't exist where it is. Its stars are mere infants by cosmic standards, less than 100 million years old, while the halo is supposed to be a retirement home for stellar relics dating back to the early universe. Yet here it glows, a sapphire anomaly drifting in a sea of golden oldies, its very presence rewriting the rules of where and how new stars can ignite. The blue blob's vibrant hue gives away its secret. Unlike the halo's typical red giants which burn cool and steady, these stars are massive, hot, and destined to live fast and die young. Their blue-white light is a telltale sign of recent birth, but that raises an obvious question. What could possibly fuel star formation in the halo's near-perfect vacuum? The answer lies in an invisible cosmic robbery. Deep spectral analysis reveals the cluster's stars are rich in heavier elements like oxygen and silicon materials forged in supernova explosions, not in the halo's primordial gas. This means the raw material for these stars didn't originate here. Instead, it was stolen. The leading theory, Andromeda's gravity ripped a gas-rich dwarf galaxy apart, funneling its interstellar material into a long, dark river of hydrogen that pooled in the halo's outskirts. Over time, turbulence in this stream caused pockets of gas to collapse, igniting a firestorm of star birth far from the galaxy's crowded disk. Hubble's ultraviolet eye has spotted similar gas filaments threading through the halo, lending credence to the idea. The blue blob might be just one of several such clusters, a glittering byproduct of galactic piracy. But there's a twist. This cluster isn't just young, it's isolated. Most young stars form in bustling nurseries surrounded by sibling clusters and leftover gas. The blue blob floats alone, its natal cloud long since dissipated. That suggests its formation wasn't just rare. It might have been a one-time cosmic fluke. Computer simulations show the conditions needed to trigger such a birth. A precise interplay of gas density, turbulence, and metallicity are extraordinarily fragile. One wrong gravitational nudge, and the gas might have scattered without forming stars at all. The implications are profound. If young clusters can form in halos, it means these dead regions might still harbor hidden pockets of star-forming potential. Perhaps halos aren't just graveyards for ancient stars, but also secret gardens where stolen gas occasionally blooms into new ones. Andromeda's blue blob might be the exception that proves a new rule, that galaxies can grow not just by swallowing stars, but by repurposing stolen gas to create fresh ones in the unlikeliest of places. Its brilliant blue light isn't just a cosmic oddity, it's a beacon illuminating the dynamic, ever-changing nature of galactic ecosystems. As astronomers continue to study this cluster, they're finding more puzzles. Its stars are rotating faster than expected, hinting at a violent birth where angular momentum was conserved in unusual ways. Some even show chemical anomalies over abundances of elements like europium that suggest the gas cloud that birthed them was enriched by a very specific type of supernova, one that's rare in modern galaxies. Every observation peels back another layer, revealing how a single stolen gas cloud can become a time capsule, preserving a snapshot of conditions we can't recreate anywhere else. For now, the blue blob burns brightly against the halo's dark canvas, a reminder that the universe never runs out of surprises. Its existence forces us to rethink not just where stars can form, but how galaxies evolve. After all, if a cluster this young can thrive in a place this old, what other cosmic contradictions are waiting to be discovered? Deep in the haze of Andromeda's halo, something invisible pulses with an eerie glow, an object that shouldn't shine at all, yet flickers with the faintest light. Astronomers call it a dark star candidate, a theoretical cosmic oddity that defies everything we know about how stars work. Unlike normal stars, which burn bright by fusing hydrogen in their cores, this one, if it exists, would draw its energy from something far stranger, the annihilation of dark matter itself. The first hint came from an anomaly in infrared surveys, a patch of the halo emitting a subtle warmth without any visible star to explain it. Spectroscopy revealed traces of helium and hydrogen, but no fingerprints of nuclear fusion, the process that powers every other star in the universe. Instead, the energy signature matched simulations of a dark star, a hypothetical beast fueled by dark matter particles colliding and destroying each other in its core, releasing just enough heat to produce a dim, cold glow. What makes this candidate so tantalizing is its location. Dark stars are thought to form only in the early universe, where dense clouds of dark matter could collapse into supermassive structures without igniting fusion. Finding one in Andromeda's halo, a relatively modern environment, would upend our understanding of how these relics can persist. Some researchers suggest it might be a primordial survivor, a first-generation dark star that somehow avoided detection for billions of years. Others propose it could be a new type of hybrid object where dark matter annihilation supplements or even replaces traditional fusion, the challenge. Confirmation is maddeningly elusive. Dark stars, by their nature, would look almost identical to dim red dwarfs or failed stars called brown dwarfs in certain wavelengths. The key difference lies in their chemical signatures and energy output. This candidate shows an excess of high-energy photons particles that shouldn't be there unless something exotic is happening beneath its surface. But with current telescopes, the signal is too faint to declare a definitive discovery. That hasn't stopped theorists from dreaming. If dark stars are real, they could solve cosmic mysteries, like why some early galaxies formed so quickly, or why we see pockets of unexplained infrared light in deep space. They might even act as dark matter factories, converting invisible particles into detectable energy at rates we've never observed. Future observatories like the James Webb Space Telescope could finally crack the case by hunting for similar objects in other galaxies, comparing their light to the whispers coming from Andromeda's halo. For now, this enigmatic glow remains a question mark, a shadow on the edge of our understanding, teasing us with the possibility that the universe's most mysterious substance might not just shape galaxies but light them from within. Every flicker in the data brings us closer to an answer or a deeper mystery still. Among the strangest couples in Andromeda's halo, there's a pair of neutron stars locked in a deadly dance, two collapsed stellar corpses separated by just a few hundred miles, whirling around each other at nearly a tenth the speed of light. These ultra-dense objects, each packing more mass than our Sun into a city-sized sphere, shouldn't normally exist in the sparse galactic outskirts, Yet here they are, catalogued as objects 16 and 17, tracing tight spirals through the halo's emptiness while broadcasting gravitational ripples across the cosmos. Their discovery challenges our understanding of where such extreme binaries form and how they survive long enough to eventually collide. Neutron star duos are cosmic gold mines for astronomers, literally and figuratively. When these incredibly dense objects merge, they forge heavy elements like gold and platinum in their explosive aftermath, precious metals that eventually seed future generations of stars and planets. But what makes this particular pair remarkable is their location. Most binary neutron stars are found in star-rich galactic disks, born from massive binary star systems that both exploded as supernova without kicking their remnants apart. Finding one in Andromeda's halo suggests a far more violent backstory. The leading theory: these neutron stars were likely ejected from Andromeda's crowded inner regions during a close encounter with a supermassive black hole. Gravitational slingshots can fling compact objects into the halo at incredible speeds, but keeping a binary pair intact during this process requires near-perfect conditions. Simulations show the original stars must have been extraordinarily close before their explosive deaths, surviving not just two supernova, but also the gravitational chaos of their escape. Their very existence proves nature can perform miracles of precision even amidst cosmic violence. As they orbit, the pair loses energy in the form of gravitational waves, ripples in spacetime predicted by Einstein and now routinely detected by observatories like LIGO. Each rotation brings them slightly closer, their dance decaying by about the width of a hydrogen atom every year. In roughly 300 million years, they'll finally merge in a cataclysm that will briefly outshine every star in Andromeda combined. The resulting kilonova explosion will blast a shower of heavy elements into the halo, while the collision itself may birth a black hole or, if the combined mass is just right, an even more massive neutron star. What makes halo mergers special isn't just their rarity, but their environment. Unlike mergers in galactic disks, which happen amid gas and dust that can obscure observations, halo collisions occur in near-perfect vacuum. When these two neutron stars finally unite, telescopes will have an unobstructed view of the fireworks, a clean laboratory for studying extreme physics. The event could reveal secrets about the nature of matter under conditions so intense that atomic nuclei dissolve into a soup of quarks, a state not seen since the universe's first microseconds. Yet this pair holds another puzzle. Precise timing of their radio pulses shows one neutron star is significantly older than its partner, suggesting they didn't form together in the same stellar nursery. The older one may have captured its companion later, perhaps after both were already wandering the halo, a cosmic meet-cute orchestrated by gravity. This unusual age gap makes their eventual merger even more scientifically valuable, as the chemical signatures of their explosion could reveal how neutron stars of different generations interact. For now, they continue their silent waltz, ticking like a cosmic clock counting down to apocalypse. Every gravitational wave they emit carries information about their composition, their orbits, and the strange physics governing matter at densities beyond human comprehension. They're not just relics, they're messengers, whispering across the halo about the universe's most extreme phenomena. And when they finally collide, the light from that explosion will carry answers to questions we haven't even thought to ask yet. In the vast sprawl of Andromeda's halo, there's a patch of sky that feels almost too quiet, a void so empty it unnerves astronomers. This region, spanning hundreds of light years, isn't just sparse, it's conspicuously vacant, as if someone took an eraser to the cosmos and scrubbed away every star, every wisp of gas, even the faintest glow of background light. Most cosmic voids are predictable, the natural ebb and flow of matter in an expanding universe, but this one, Object 18, defies expectations. It's not just a gap, it's a cosmic blind spot, a place where the rules of galactic structure seem to break down. The first red flag came from deep field surveys. While mapping Andromeda's halo, telescopes picked up a sudden drop in starlight density, not a gradual fade, but a sharp cutoff, like stepping off a cliff into darkness. Follow-up observations with radio and X-ray telescopes found no hint of gas or dust to explain the absence. Even the cosmic microwave background, the universe's faint afterglow, dips slightly when passing through this zone, as if something is absorbing its photons. Statistically, the odds of such a perfect void forming naturally are astronomically low. So what's really going on? One theory points to an invisible predator lurking in the dark, a cluster of primordial black holes. These hypothetical relics, thought to have formed in the chaos of the Big Bang, could be drifting through the halo like ghostly piranhas, their gravity clearing the area of stars and gas over billions of years. Unlike stellar black holes, which form from collapsing stars, primordial ones could be any size from subatomic to supermassive, making them perfect candidates for stealthy cosmic vandalism. If they exist, their combined gravity would explain the void's pristine emptiness without leaving a visible trace. But there's a catch. Primordial black holes have never been directly detected, and their existence remains speculative. Some physicists propose an even stranger explanation, a cosmic defect left over from the early universe, like a tear in spacetime's fabric. These theoretical structures, called textures or domain walls, could create regions where matter is repelled rather than attracted, effectively pushing stars and gas out like a force field. While rare, such defects would naturally carve out perfectly clean voids, no black holes required. Then there's the mundane possibility. Maybe we're just seeing a statistical fluke, a freak accident of distribution. Halos are lumpy by nature, with clumps of dark matter and stars scattered unevenly. Perhaps this void is simply the universe's version of rolling 100 dice and getting all ones, unlikely but not impossible. Yet even this explanation feels unsatisfying. The void's edges are too sharp, its emptiness too total. It's as if the region was deliberately emptied, not randomly overlooked. The mystery deepens when you consider what lies just beyond the void's border. Telescopes have spotted stellar streams bending unnaturally as they approach the edge, their trajectories warped as if something massive, but invisible, lurks just out of sight. Gravitational lensing measurements hint at an unseen mass, but there's no concentrated glow or X-ray signature to indicate a traditional black hole or dark matter cluster. It's as if the void itself has gravity, a phantom presence bending light without a source. Could this be a window into dark matter's true nature? Some models suggest certain types of dark matter particles might clump into ultra-dense cores that repel normal matter, creating bubbles of nothingness in their wake. Others speculate the void might be the aftermath of an ancient collision between Andromeda and another galaxy, a scar where two halos' dark matter structures cancelled each other out in a perfect cosmic accident. For now, the void remains a silent enigma, a blank spot on the map that refuses to be filled. Every observation raises new questions. Is it a sign of new physics, a relic of the universe's birth, or just a trick of the light? The answer, if we ever find it, could rewrite our understanding of how galaxies assemble their halos, and what secrets those halos still hide. Until then, this empty patch of sky stands as a humbling reminder. Sometimes the universe's most profound statements aren't written in stars, but in the spaces between them. One of the most violent fugitives in Andromeda's halo isn't a star or a black hole. It's the shredded remains of an exploded star racing through space at breakneck speed. This supernova remnant, known as Object 19, isn't just drifting lazily like most stellar debris. It's barreling through the halo at over 2 million miles per hour, leaving a twisted trail of glowing gas and bow shocks in its wake. Most remnants expand outward symmetrically like a perfect bubble, but this one, it's stretched and distorted, its shock waves rippling unevenly through the halo's sparse gas, a telltale sign that its death wasn't just explosive but profoundly lopsided. When a massive star dies, the supernova explosion usually sends debris flying outward in all directions. But sometimes, if the blast is asymmetrical, perhaps due to a hidden companion star or turbulent magnetic fields, the collapsing core can recoil like a cosmic cannon, kicking the remnant in one specific direction. That's likely what happened here. Observations from X-ray telescopes reveal a dense knot of material at one edge of the remnant, probably the neutron star or black hole left behind, hurtling ahead of the expanding gas like a bullet leading its own shrapnel cloud. The force of its kick was so extreme, it escaped the star-forming region where it was born, venturing into the halo's near-empty expanse, an interstellar outcast with a turbulent past written in its wake. What makes this remnant truly mesmerizing is how it interacts with its surroundings. As it plows through the halo's diffuse gas, it generates shock waves that heat the material to millions of degrees, causing it to glow in X-rays. Radio telescopes have mapped these turbulent edges, revealing intricate filaments where atomic particles are accelerated to near light speed, creating eerie ripples of synchrotron radiation. The slower-moving debris at the remnant's rear forms delicate, lace-like structures, while the leading edge is a chaotic mess of compressed gas and magnetic fields like a ship's bow cutting through an invisible ocean. Theories about its origin are just as fascinating. Some astronomers suspect the doomed star was once part of a binary system, and its partner's gravity skewed the supernova's explosion, turning the dying star's core into a celestial projectile. Others suggest it might have been born in a dense cluster near Andromeda's center, where gravitational interactions with neighboring stars could have amplified its kick. Either way, its velocity is rewriting our understanding of how stellar corpses can be ejected into galactic hinterlands. Most neutron stars and remnants stay close to their birthplaces, but this one is a renegade, proving that even in death, stars can defy expectations. Then there's the lingering mystery of its age. By measuring the remnant's expansion rate and comparing it to the density of halo gas it's plowing through, researchers estimate the supernova occurred roughly 50,000 years ago. Yet its speed suggests it's traveled much farther than expected for something that young. This discrepancy hints at another possibility. Maybe the halo's gas isn't as uniformly distributed as we thought. The remnant could be carving through pockets of higher density, slowing unpredictably like a car hitting patches of mud, which would throw off distance calculations. Alternatively, its initial kick might have been even more violent than current models allow. This runaway remnant isn't just a spectacle, it's a time capsule. The composition of its debris holds clues about the star that created it, from the heavy elements forged in its final moments to the exotic physics of its asymmetric explosion. Every ripple in its shockwaves is a data point, helping astronomers map the halo's invisible structure, and perhaps most intriguingly, its path might lead us to other hidden relics. If one remnant can be ejected this ferociously, there could be more out there, silent, high-speed ghosts from ancient stellar deaths, streaking through the darkness where we least expect them. As it continues its journey, the remnant will eventually disperse, its energy bleeding into the halo's void. But for now, it's a blazing testament to the chaos of stellar life cycles, a reminder that even in the quietest corners of a galaxy, the echoes of catastrophe still reverberate. Lurking in the silent depths of Andromeda's halo, there's a galaxy so faint, it almost disappears into the cosmic background, a wispy, ethereal structure known as an ultradiffuse galaxy. Unlike the dense, star-packed spirals we're familiar with, this ghostly collection of stars, catalogued as Object 20, is so thinly spread that if you stood within it, the night sky would appear nearly as empty as intergalactic space. Its stars are so sparse, you could cross its entire length without encountering another stellar neighbor for light years. Yet against all odds, this fragile cosmic cobweb has survived for billions of years, untouched by the gravitational turbulence that shreds similar structures. How does something so delicate endure in a universe ruled by chaos? The answer lies in its stealth. Ultradiffuse galaxies are cosmic phantoms, their stars scattered so wide that their collective gravity is barely enough to hold them together. Most galaxies this size would have been torn apart long ago, either by Andromeda's tides or collisions with other dwarf galaxies. But Object 20 floats through the halo like a feather on a breeze, its stars so thinly distributed that tidal forces simply pass through them without gaining enough grip to disrupt the structure. Imagine trying to rip apart a handful of smoke. That's the challenge Andromeda's gravity faces when it encounters this wispy relic. What's even more puzzling is how this galaxy formed in the first place. Its stars are ancient, nearly as old as the universe itself, and their chemistry suggests they were born in a calm, isolated pocket of space, far from the violent mergers that build typical galaxies. Some researchers propose it might be a failed galaxy, a structure that started gathering gas in the early universe but never accumulated enough to ignite vigorous star formation. Others speculate it could be the remnant of a once larger galaxy, its outer stars stripped away over eons, leaving only the most loosely bound core behind. Yet the real mystery isn't just its survival, it's what's missing. Ultradiffuse galaxies like this one should, by all rights, be dominated by dark matter, their invisible halos providing the extra gravity needed to explain their stability. But when astronomers measured the motions of Object 20 stars, they found something startling. There's hardly any dark matter here at all. The stars move as if they're floating freely, their velocities too slow to be held by unseen mass. This flies in the face of everything we know about galaxy formation. Dark matter is supposed to be the scaffolding that holds galaxies together, especially fragile ones. So how does this galaxy exist without it? One radical theory suggests Object 20 might be a tidal dwarf, a galaxy born from debris flung out during a past collision between larger galaxies, rather than from pristine primordial gas. Such galaxies could form with little to no dark matter, inheriting only the visible material ejected during the chaos. If true, that would make this ultra-diffuse galaxy a second-generation structure, a cosmic orphan born from violence rather than quiet collapse. Supporting this idea are subtle clues in its stellar orbits, which show patterns more consistent with a disrupted origin than an undisturbed one. But here's where the plot thickens. Recent deep surveys have revealed a handful of other ultra-diffuse galaxies in Andromeda's halo, each as enigmatic as the last. Some are pristine and dark matter rich, while others, like Object 20, defy the mold entirely. This diversity suggests there might be multiple ways to build and preserve these celestial ghosts. Perhaps they're not all failed galaxies or tidal remnants, but a mix of survivors, each with its own unique creation story. The discovery of galaxies like this forces us to rethink the limits of galactic resilience. If something so diffuse can endure for billions of years in a hostile environment, what else might be hiding in plain sight? Every faint star in Object 20 is a testament to the universe's creativity, proving that even the most fragile structures can outlast the cosmos's chaos if they're subtle enough to slip through the cracks. As telescopes grow more sensitive, who knows how many more of these ghosts we'll find, floating silently in the halos of galaxies, waiting to tell their stories. Deep within Andromeda's halo, astronomers have stumbled upon a cosmic anomaly that crackles with invisible energy, a mysterious hotspot where the intensity of cosmic rays spikes to levels unseen anywhere else in the galaxy. These ultra-high-energy particles, mostly protons and atomic nuclei traveling at nearly light speed, bombard this region like a relentless hailstorm, their origins shrouded in mystery. What makes this cosmic ray hotspot Object 21 so unnerving isn't just the radiation itself, but the fact that no visible source explains it, no supernova remnants. No pulsars, just empty space seething with particles that carry more energy than anything humans can produce in our most powerful accelerators. The first clues came from gamma-ray telescopes, which detected an unusual excess of high-energy photons radiating from this patch of the halo. But gamma rays are just the secondary signature, the aftermath of cosmic rays colliding with interstellar gas. Tracing these photons back to their source led scientists to an even bigger shock. The cosmic rays here aren't just plentiful, they're more energetic than standard astrophysical processes should allow. Some register at exact electronvolt levels that's 1 billion times more powerful than particles in the Large Hadron Collider. To produce such extreme energies, you'd need an accelerator of cosmic proportions, something far beyond a typical supernova or neutron star. One prevailing theory points to dark matter annihilation. If hypothetical weakly interacting massive particles WIMP collide and destroy each other in Andromeda's halo, they could theoretically release bursts of energy that decay into cosmic rays. The hotspot's location aligns with areas where dark matter density models predict such interactions might peak. But there's a catch. No one's ever definitively detected dark matter particles, much less their annihilation signals. The cosmic ray excess could just as easily stem from something far more mundane, like a hidden pulsar wind nebula or a defunct quasar buried in the halo's depths. Then there's the wild-card explanation, a natural particle accelerator of unimaginable scale. Some astrophysicists speculate that turbulence in Andromeda's halo, perhaps from ancient shockwaves of long-dead supernova, could create magnetic structures that slingshot particles to extreme velocities. These pevatrons, as they're called, would function like cosmic versions of human-made cyclotrons, but on a galactic scale. The problem, we've never observed one directly. If they exist, their magnetic fields would be too diffuse and chaotic to image with current technology, leaving only their particle debris as evidence. What makes this hotspot particularly tantalizing is its shape. Most cosmic ray sources produce roughly spherical radiation patterns, but this one is elongated, stretching across hundreds of light years like a celestial lightning bolt. Radio observations reveal faint filamentary structures within the zone, threads of magnetized plasma that might trace the paths of accelerated particles. These filaments bear an eerie resemblance to Earth's auroral curtains, hinting at massive electric currents flowing through the halo's near-perfect vacuum. Some researchers wonder if we're seeing the aftermath of a black hole's feeding frenzy, a jet from an active galactic nucleus that shut off millions of years ago, leaving behind an invisible particle highway. The implications reach far beyond Andromeda. Cosmic rays at these energies can travel intergalactic distances, meaning this hotspot might be contributing to the mysterious ankle in the cosmic ray spectrum, a sudden increase in particle energies that astronomers have struggled to explain. If dark matter truly is the culprit, this could be our first indirect glimpse of its particle nature. If it's a natural accelerator, it challenges our understanding of how particles gain energy in the universe's most extreme environments. For now, the hotspot remains an enigma, its particles bombarding our detectors like coded messages from the halo's depths. Every new observation adds another piece to the puzzle, but the full picture keeps slipping just out of reach. Whether it's dark matter's whisper or the ghost of a long-dead cosmic engine, one thing is certain. In the quiet expanse of Andromeda's halo, something extraordinary is cranking nature's dial to 11, and we're only just beginning to hear the static. Nestled within Andromeda's halo, there's a star cluster that shouldn't fit in a glittering knot of stars with a chemical fingerprint identical to the galaxy's bustling disk, yet stranded light years away in the sparse outskirts. This celestial oddity, Object 22, is like finding a piece of a shattered mirror reflecting a scene from another place and time. Its stars aren't the ancient, metal-poor relics typical of the halo. They're young, rich in heavy elements, and unmistakably born in the crowded, star-forming heart of Andromeda. So how did this fragment of the disk end up so far from home? The answer lies in a cataclysmic encounter, a gravitational upheaval violent enough to fling an entire stellar family into the galactic wilderness. Reconstructing this cosmic crime scene starts with the cluster's chemistry. Spectroscopy reveals an abundance of iron, oxygen, and even trace elements like europium, materials forged in the intense heat of supernova and stellar winds, signatures of a birthplace drenched in generations of star death and rebirth. These elements are the calling cards of Andromeda's disk, where star formation has been ongoing for billions of years. Yet here they are, glowing defiantly in the halo, a chemical mismatch that tells a story of dislocation. The cluster's stars share nearly identical ages and compositions, like siblings separated at birth, hinting they were ripped away as a single unit rather than scattered individually over time. The most likely culprit, a high-speed collision with another galaxy. Simulations suggest that when Andromeda cannibalized a smaller galaxy billions of years ago, the gravitational shockwaves could have plucked entire star clusters from the disk's edges, hurling them outward like debris from a car crash. Picture the chaos as the intruder galaxy plunged through Andromeda's disk. Its gravity would have tugged violently on nearby stars, accelerating some to escape velocity while leaving others behind. The cluster we see today might be one of the lucky survivors, a cohesive group that held together despite the gravitational turbulence, sailing into the halo on a trajectory that stranded it permanently. But here's the twist: this cluster isn't alone. Deep surveys have uncovered several similar fragments scattered throughout the halo, all with disk-like chemistry, all telling different chapters of the same violent story. Some are stretched into elongated streams, evidence of slower, more drawn-out disruption. Others, like Object 22, remain miraculously intact, their tight gravitational bonds resisting total destruction. Together, they form a hidden archaeological record, a trail of breadcrumbs leading back to the moments when Andromeda's structure was violently reshaped. The real surprise is how little these stars have aged. Unlike the halo's typical ancient populations, this cluster's stars are relatively youthful, some as young as a few 100 million years, proving that disk material was still being ejected long after Andromeda's early, chaotic growth spurts. That means the galaxy isn't just a relic of ancient collisions. It's a dynamic entity, still rearranging itself through violent encounters even today. Every star in this cluster is a witness, a piece of evidence in a cosmic cold case that's still unfolding. This fragment isn't just a curiosity, it's a key to understanding galactic evolution. By studying its orbit, astronomers can trace the path of the long-vanished galaxy that disturbed it, reverse engineering the collision that sent it flying. Its chemistry offers a snapshot of Andromeda's disk at the moment of ejection, a time capsule preserving conditions from an era we can't otherwise observe. And its very existence challenges assumptions about how tightly bound star clusters really are. If gravity can hold them together through such trauma, perhaps many more of these mirror fragments are drifting undetected, waiting to be found. As telescopes peer deeper into Andromeda's halo, each new discovery like this one adds another layer to the story. The universe doesn't just build galaxies, it tears them apart, stitches them back together, and flings pieces of them into the void. And sometimes, if we're lucky, those pieces shine brightly enough for us to piece together what happened. This cluster is more than a celestial anomaly. It's a postcard from a violent past sent across billions of years to remind us that even the grandest structures in the cosmos are shaped by chaos. At the fringes of Andromeda's halo, a dying star burns with unexpected defiance, a red giant so luminous it outshines its peers by a factor of 10. This aging stellar behemoth, catalogued as Object 23, radiates with an intensity that baffles astronomers. Red giants are supposed to follow predictable paths as they near the end of their lives, their brightness and size governed by well-understood physics. But this one, it's breaking all the rules, shining brighter than any model says it should, as if it's stealing extra fuel from some unseen cosmic reservoir. The first clue to its strangeness came from infrared surveys, which revealed its inflated outer layers stretching nearly as wide as Earth's entire solar system. At that size, it should glow with a predictable warmth, yet spectroscopic measurements show its surface temperature is hundreds of degrees hotter than comparable stars. This isn't just a slight discrepancy, it's a fundamental mismatch between theory and observation. Something is energizing this star beyond its natural limits, and astronomers are locked in a debate over what that could be. One camp argues we're witnessing a rare evolutionary stage, a superwind phase where the star sheds its outer envelope in violent, sporadic bursts. Normally, red giants lose mass gradually, like sand trickling through an hourglass. But in this scenario, Object 23 might be experiencing episodic eruptions, ejecting vast clouds of material that briefly expose its hotter inner layers before they cool and reform. These fits of stellar coughing would explain the irregular brightness spikes, but they'd also imply we've caught this star in a fleeting, unstable moment, one that only a handful of stars experience before collapsing into white dwarfs. The competing theory is far more intriguing. This red giant isn't alone. Hidden in its glare could be a companion, a white dwarf or neutron star locked in a slow cosmic dance, siphoning material from the giant's puffy outer layers. As this stolen gas spirals toward the dense companion, it would heat up to millions of degrees, emitting X-rays and bathing the red giant in intense radiation. This extra energy could explain the star's unnatural glow, essentially turning it into a cosmic light bulb powered by gravitational theft. Supporting this idea are faint, periodic fluctuations in the star's light curve, tiny dips and surges that hint at an unseen object tugging on it with clockwork regularity. Then there's the wildcard possibility, magnetic mischief. Some red giants develop extraordinarily strong magnetic fields as their cores contract, twisting their outer layers into chaotic loops that trap heat and delay cooling. Imagine a star with magnetic blankets wrapped around it, holding in energy that would otherwise escape. If Object 23's magnetic fields are unusually potent, they could be distorting its entire energy output, creating a luminosity anomaly unlike anything we've documented before. The stakes are higher than they seem. If this star is a rare evolutionary outlier, it could reshape our models of stellar life cycles, proving that some stars take dramatic detours on their way to oblivion. If it's hiding a companion, it offers a preview of our own sun's distant fate billions of years from now. After it becomes a red giant, it too may share its skies with the white dwarf corpse of Earth. And if magnetism is the culprit, it challenges our understanding of how stellar interiors behave under extreme conditions. For now, telescopes remain fixed on this stellar rebel, dissecting its light for answers. Every wavelength tells a different part of the story. The infrared reveals its expansive outer layers, the X-rays hunt for signs of a hidden partner, and radio waves probe its magnetic personality. Whatever the truth turns out to be, one thing's certain. In the quiet expanse of Andromeda's halo, even the oldest, most predictable stars can still surprise us. This red giant isn't just a dying ember, it's a cosmic question mark burning brighter than it has any right to, and daring us to figure out why. Among the most elusive structures in Andromeda's halo is something no telescope can see, a shadowy thread of dark matter stretching like a cosmic umbilical cord to one of the galaxy's diminutive satellites. This invisible filament, known as Object 24, isn't made of stars or gas. It's a gravitational lifeline, a bridge of pure mass tethering Andromeda to its smaller companion through the silent pull of the universe's most mysterious substance. The first hints of this dark matter bridge came not from light but motion. Astronomers tracking stars in the dwarf galaxy NGC 205 noticed their orbits didn't behave as expected. Instead of drifting freely through the halo, they appeared subtly tugged, as if anchored by an unseen force. Computer simulations revealed the culprit, a narrow, river-like flow of dark matter connecting the satellite to its massive host. Unlike the smooth, diffuse halo surrounding Andromeda, this filament is dense and focused, a cosmic tightrope woven from gravity itself. Detecting something invisible requires clever detective work. By mapping the precise velocities of stars in NGC 205, researchers could calculate the gravitational forces at play, revealing where extra mass must be hiding. The data painted a clear picture. Stars near the filament's predicted path moved faster than those elsewhere, their acceleration betraying the dark matter's grip. It's like inferring the shape of a buried pipe by watching how water flows above it. The filament's influence even distorts the dwarf galaxy's shape, stretching it slightly toward Andromeda like taffy pulled between two hands. This discovery isn't just about one odd structure, it's a window into how galaxies grow. According to cosmological models, dark matter forms an invisible cosmic web, a sprawling network of filaments that guide galaxies together like beads on a string. Over billions of years, gravity draws matter along these threads, fueling the growth of galactic giants like Andromeda. Spotting an actual filament in action validates decades of theory, offering tangible proof that dark matter's scaffolding truly shapes the universe. Yet mysteries remain. The filament's density seems higher than simulations predicted, suggesting dark matter might clump more tightly at small scales than we thought. Some researchers propose this could hint at exotic dark matter properties, particles that interact weakly with each other, creating denser knots. Others speculate the bridge might be a relic of the dwarf galaxy's initial capture, a gravitational wake left behind as it plunged into Andromeda's halo. Every new observation adds nuance to the story, revealing how dynamic these invisible connections really are. What's next for this shadowy bridge? Over cosmic time, tidal forces will likely tear NGC 205 apart, its stars scattering into Andromeda's halo. But the dark matter filament may persist, a fossilized trace of a meal consumed long ago. Future telescopes like ESA's Euclid or NASA Roman could map similar filaments across the local universe, exposing the hidden architecture that binds galaxies together. For now, this silent thread stands as a reminder. The universe's grandest structures aren't always the brightest. Sometimes they're the ones we feel but never see, the ghostly hands that sculpt the cosmos. Far beyond Andromeda's swirling disk, an interstellar intruder is making a chaotic entrance, a high-velocity cloud of gas, hundreds of light-years wide, screaming through the halo at nearly 2 million miles per hour. This rogue structure, Object 25, isn't just drifting lazily like most halo gas. It's a cosmic bullet plowing through Andromeda's outskirts with such force. It's carving shockwaves through the sparse medium like a speedboat through glassy water. The collision zone glows with ultraviolet fury, a luminous testament to the violence of intergalactic weather. This isn't some ordinary gas cloud. Its extreme velocity and peculiar chemistry betray an exotic origin. Spectroscopic analysis reveals a severe lack of heavy elements, just hydrogen and traces of helium, as pristine as the raw material of the Big Bang. That purity points to a birthplace far from Andromeda's metal-polluted disk, likely the intergalactic medium itself. Imagine a shard of the universe's primordial atmosphere, untouched by stellar furnaces for billions of years, suddenly knocking on Andromeda's door with enough kinetic energy to power 1,000 supernovae. The cloud's impact is rewriting the halo's ecology. As it rams into Andromeda's diffuse gas, it compresses the material ahead of it, triggering spontaneous pockets of star formation. In its wake, blue sparks of newborn stars flickering to life where none should exist. Meanwhile, behind the shock front, turbulence churns the gas into intricate filamentary structures, visible only to radio telescopes tuned to the whispers of cold hydrogen. These chaotic swirls aren't just beautiful, they're clues to the halo's hidden structure, tracing the distribution of dark matter that subtly guides the wreckage. But the real mystery is the cloud's survival. Gas clouds this diffuse should disintegrate when subjected to such forces, torn apart like fog in a hurricane. Yet this one holds together, its coherence hinting at an invisible scaffold, perhaps a thread of dark matter, or magnetic fields woven through it like cosmic stitching. Some theorists propose it's not a cloud at all, but the visible tip of a much larger, unseen structure, a dark matter subhalo dragging its gaseous tail through Andromeda's outskirts. Others speculate it could be a remnant of the cosmic web, one of the universe's primordial filaments caught in the act of feeding a galaxy. The collision is playing out in slow motion by human standards, but its aftermath will linger for eons. Each shockwave propagates outward, subtly redistributing the halo's sparse gas, while the cloud itself will eventually decelerate, its material mingling with Andromeda's like cream swirling into coffee. Future astronomers might find no trace of this violent encounter, just a slightly enriched halo and perhaps a few odd stellar clusters with peculiar orbits, the only witnesses to the day the galaxy's quiet outskirts became a cosmic battleground. For now, though, the cloud is a fleeting laboratory. Its extreme conditions let us study gas dynamics at scales impossible to replicate in simulations, offering glimpses into how galaxies accrete fresh material from the void. Every distorted hydrogen line in its spectrum, every flicker of newborn starlight at its edges, tells a story, not just about this cloud, but about the invisible currents that shape galaxies from the outside in. In the grand timeline of Andromeda's life, this collision is just a momentary spark, but for us, it's a front-row seat to the forces that have built the cosmos since the beginning. Rising like titanic hourglasses from Andromeda's core, twin gamma-ray bubbles stretch tens of thousands of light-years into the halo, vast, symmetrical structures crackling with the highest energy photons in the universe. These colossal formations, objects 26 and 27, glow faintly in gamma-ray telescopes as ghostly silhouettes against the halo's darkness, their perfect alignment above and below the galactic plane hinting at an ancient cataclysm of unimaginable power. What makes these bubbles extraordinary isn't just their scale. Each could swallow the Milky Way whole, but the fact that we've seen something eerily similar closer to home, our own galaxy's Fermi bubbles. Yet Andromeda's versions are larger, brighter, and far more mysterious, challenging everything we thought we knew about galactic outbursts. The discovery came when gamma-ray observatories mapped the halo's high-energy emissions, expecting a smooth distribution. Instead, they found two distinct lobes of gamma radiation, their edges razor-sharp where they meet the halo's diffuse gas. Unlike the messy debris fields of supernova or the tangled filaments of star-forming regions, these bubbles are unnervingly symmetrical, like the afterimage of a cosmic explosion frozen in time. Their gamma-ray signature suggests particles within them are being accelerated to near light speed, possibly by shock waves from some long-ago event near Andromeda's core. But what event could produce energy on this scale? The leading suspect, Andromeda's supermassive black hole. Most large galaxies host quiescent black holes, but occasionally, these monsters awaken in violent feeding frenzies known as active galactic nucleus and phases. During these episodes, the black hole's accretion disk becomes a colossal particle accelerator, spewing jets of charged material that inflate bubbles of hot gas into the halo. While Andromeda's black hole sleeps today, the bubble's size and energy implied was anything but dormant in the past. Computer simulations show an Aegean outburst could have launched these structures roughly 2 to 5 million years ago. A blink in cosmic terms, the gamma-ray glow representing the fading echo of that catastrophe. Yet there's a puzzling discrepancy. The Milky Way's Fermi bubbles, though smaller, show remarkably similar structure, yet our galaxy's central black hole shows no evidence of recent Aegean activity powerful enough to create them. This paradox has led some astronomers to propose alternative origins for both sets of bubbles. One radical theory suggests they could be remnants of dark matter annihilation, where hypothetical particles collide and decay into gamma rays in concentrated zones near galactic centers. Another posits that clusters of supernova exploding in rapid succession, a phenomenon called a starburst, could collectively blow such bubbles into the halo. Comparing Andromeda's bubbles to the Milky Way's reveals subtle but crucial differences. Andromeda's lobes show more pronounced substructure, filaments and knots of intense emission suggesting multiple outbursts or complex interactions with the halo's magnetic fields. The Milky Way's bubbles, by contrast, appear smoother, possibly indicating a single, more uniform event. Both, however, share an odd chemical fingerprint, an overabundance of high-energy positrons, the antimatter counterparts to electrons. This signature complicates the AGN explanation, as black hole jets typically produce different particle mixes, fueling speculation that both galaxies might harbor unknown particle acceleration mechanisms. New observations add even more intrigue. Deep within Andromeda's bubbles, radio telescopes have detected faint synchrotron radiation, the telltale shimmer of electrons spiraling around magnetic field lines. This implies the bubbles aren't just hot gas, they're threaded with invisible magnetic scaffolding, possibly shaped by the galaxy's rotation or distorted by encounters with dark matter. Some researchers even speculate that the bubbles might be leaking, their high-energy particles spraying into intergalactic space, subtly influencing the cosmic web on scales far beyond Andromeda itself. The implications stretch beyond any single galaxy. If AGN outbursts are responsible, these bubbles could be fossil records of how supermassive black holes regulate galaxy growth, periodically heating their halos to prevent runaway star formation. If dark matter or starbursts are the cause, they might represent entirely new astrophysical phenomena. Future gamma-ray telescopes could settle the debate by mapping the bubble's fine structure or searching for similar features in distant galaxies. For now, these twin enigmas float above and below Andromeda's disk. Their gamma-ray glow a cryptic message from the galaxy's violent past, a reminder that even the quietest giants can have tempestuous histories written in light we're only beginning to read. At the edge of Andromeda's halo, a cosmic phoenix refuses to die, a white dwarf star that's cheated death not once but multiple times. This stellar zombie, catalogued as Object 28, bears the scars of repeated supernova explosions, a feat that defies everything we know about how stars meet their end. Most white dwarfs are quiet embers, the cooling cores of dead stars destined to fade slowly into darkness. But this one, it's a relic of chaos, a celestial survivor with a composition so bizarre, it's rewriting the rules of stellar evolution. What makes this white dwarf extraordinary isn't just its history, it's what's lurking beneath its surface. Spectroscopic analysis reveals an atmosphere polluted with heavy elements like oxygen, neon, and even traces of silicon. That's the chemical fingerprint of a star that's lived through hell and back. Normally, white dwarfs are pristine, their gravity pulling heavier elements into their cores while only lightweight hydrogen or helium floats to the surface. But this one is littered with stellar shrapnel, the debris of explosions that should have torn it apart completely. The leading theory is as mind-bending as the star itself. Astronomers suspect this white dwarf was once part of an ultra-close binary system, orbiting another star so tightly that their gravitational dance became a death spiral. As the partner star aged and expanded, the white dwarf siphoned material from its outer layers, growing heavier until it reached a critical mass, triggering a thermonuclear explosion known as a Type I supernova. But here's where the story twists. Most white dwarfs are obliterated in these blasts, vanishing in a flash of light. This one somehow survived, its core intact, left to wander the halo as a rogue remnant. Even more astonishing, the evidence suggests this wasn't a one-time event. The star's peculiar mix of elements points to multiple explosions. a series of failed supernovae that each blasted away part of its outer layers while leaving the core stubbornly intact. Imagine a firework that ignites, explodes, then reassembles itself mid-air only to detonate again. That's the cosmic contradiction we're dealing with here. How does a star endure such violence? The answer may lie in its spin. Some models suggest rapid rotation could act like a cosmic shield, stabilizing the white dwarf during explosions by distributing energy more evenly. Others propose exotic magnetic fields strong enough to contain the blasts like an invisible bottle. Whatever the mechanism, the result is the same, a stellar Lazarus rising from its own ashes not once but repeatedly. This zombie star isn't just a curiosity, it's a time capsule. Its polluted atmosphere preserves elements forged in supernova that we can't replicate in labs, offering clues about the nuclear reactions that power these colossal explosions. Its very existence challenges our classification of supernova, proving that some stars don't follow the textbook endings we've written for them. And if one such survivor exists, there could be others lurking in the halos of galaxies, hiding in plain sight until we learn how to recognize them. For now, this white dwarf drifts through Andromeda's halo, a silent witness to the universe's capacity for defiance. Every atom in its scarred surface tells a story of survival, of resurrection, of the blurred line between destruction and endurance. It's a reminder that even in the cold equations of astrophysics, there's always room for the extraordinary. Deep in the silent reaches of Andromeda's halo, gravity tells a story that light cannot, a tale of an entire galaxy that never was, a shadowy structure detectable only by the way it bends the fabric of space around it. This invisible dwarf galaxy, Object 29, defies every expectation. It has the mass of a small galaxy, perhaps 1 billion suns, yet almost no stars to account for it. Telescopes see nothing but darkness where gravity insists something substantial must lurk, a cosmic contradiction that has astronomers questioning how galaxies form and why some fail to shine. The discovery came not from starlight but from the subtle distortions of background galaxies behind it, an effect called weak gravitational lensing. As light from distant objects passes through the dwarf's gravitational field, it bends ever so slightly, like a mirage shimmering in desert heat. Precise measurements of these distortions revealed the unseen mass, mapping its shape and density with surprising clarity. The data paints a picture of a classic dwarf galaxy, compact, roundish, and roughly the size of the Large Magellanic Cloud, but with one glaring omission. Where there should be glittering stars, there's only void. What could leave a galaxy so dark? One compelling theory points to a primordial misstep. In the early universe, galaxies formed where dark matter clumped together, creating gravitational wells for gas to pool and eventually ignite into stars. But in rare cases, something might have gone wrong. Perhaps this dwarf formed in an unusually quiet pocket of the cosmos, where the gas was too diffuse or too hot to collapse efficiently. Or maybe it was born just a bit too late, after the universe's expansion had diluted matter enough that star formation became impossible. Without stars to enrich it with heavy elements, the gas might have remained inert, a celestial stillbirth frozen in time. But there's a darker possibility. Some simulations suggest that in certain environments, ultraviolet radiation from the first generation of stars could have sterilized nearby gas clouds, stripping them of their ability to cool and form stars. This cosmic reionization might have left behind galaxies like Object 29, places where dark matter gathered as usual, but the ordinary matter was effectively stillborn. Supporting this idea are faint traces of hydrogen detected in radio waves, the last whispers of gas that never ignited. The sheer emptiness of this structure suggests it's not just a dim galaxy, it's a fossil of a time when the universe itself conspired against light. Yet the most tantalizing question isn't just why it failed to form stars, but what's lurking in its depths today. Could there be rogue planets adrift in the darkness? Or black holes left behind by fleeting, failed stars, Some theorists even speculate that ultra-diffuse star clusters might be hiding in its shadows, their light too feeble to detect. Future telescopes with infrared capabilities might peel back the veil, searching for the faint glow of brown dwarfs or orphaned stellar remnants, hints that this galaxy wasn't always completely dark. This invisible dwarf isn't just an oddity, it's a mirror held up to our theories. If dark matter really outweighs visible matter 5 to 1, then structures like this should be everywhere. Yet finding them is like searching for ghosts. We only notice them when they pass between us and something brighter. Their existence forces us to confront how little we know about the invisible scaffolding of the cosmos, and how many more of these shadow galaxies might be drifting unseen, rewriting the rules of galactic evolution with their silence. The discovery also raises profound questions about Andromeda's past. Was this dwarf always so dark, or did something strip it of its stars long ago? Tidal interactions with Andromeda could have torn away any fledgling stellar populations, leaving only the dark matter halo behind. Or perhaps it's a survivor from an earlier cosmic era, a relic of a time when dark galaxies outshone their visible counterparts. Every new observation peels back another layer, revealing how galaxies both bright and dark are shaped by forces we're only beginning to understand. For now, Object 29 remains an enigma, its presence felt but not seen, its story written in gravity rather than light. It's a reminder that the universe hides its secrets in plain sight, waiting for us to look not just with our eyes but with the subtle tools of inference and imagination. And somewhere out there, in the vast expanse of Andromeda's halo, other invisible dwarfs may be waiting silent witnesses to the unseen architecture of the cosmos. At the very edge of Andromeda's influence, where the galaxy's sprawling halo finally surrenders to the void, there's an invisible frontier, a faint, rippling shockwave marking the boundary between galactic dominion and the untamed wilderness of intergalactic space. This elusive structure, Object 30, isn't a physical barrier but a cosmic bow shock, the galaxy's equivalent of a ship's wake as it plows through the sparse gas of the universe. Imagine Andromeda sailing through the cosmos, its immense gravity compressing and heating the thin intergalactic medium ahead of it, creating a subtle yet detectable pressure wave where the galaxy meets the nothingness beyond. What makes this shock boundary extraordinary isn't just its existence, it's what it reveals about Andromeda's journey through space and time. As the galaxy moves, it interacts with the filaments of the cosmic web, the vast network of gas and dark matter threading the universe. The shockwave forms where Andromeda's halo gas collides with these external currents, creating a turbulent zone of heated particles and weak radio emissions. Telescopes tuned to low-frequency wavelengths have mapped its faint glow, tracing a jagged outline that looks less like a smooth edge and more like a frayed ribbon, twisted by the chaotic flows of the intergalactic medium. This boundary isn't static, it's a dynamic interface where the galaxy's fate is subtly shaped. The shockwave acts as a filter, regulating how much intergalactic gas can penetrate Andromeda's halo and eventually fuel future star formation. Some material is deflected while other streams slip through, guided by the halo's invisible dark matter scaffolding. These inflows are crucial. Without fresh gas, galaxies would eventually starve, their stellar factories grinding to a halt. But the shock boundary also has a defensive role, protecting Andromeda's delicate halo chemistry from being diluted by the metal-poor gas of the cosmic void. The shock structure holds clues to Andromeda's past collisions, too. Simulations show that mergers with smaller galaxies leave scars in these outer regions, distorting the shockwave's shape like fingerprints in cosmic clay. By studying its asymmetries, astronomers can reconstruct the galaxy's violent history, the ancient impacts that sent ripples through its halo, or the gravitational tugs of unseen dark matter clumps lurking just beyond the edge. It's a celestial bulletin board posting announcements of every major event in Andromeda's life. But the most tantalizing detail lies in what this boundary means for the future. In about 5 billion years, Andromeda and the Milky Way will collide, their halos merging long before their stars do. When that happens, these shock boundaries will be the first to interact, a prelude to the cosmic dance ahead. The gas halos will compress and heat, triggering waves of star formation, even as the galaxies themselves remain far apart. The shock waves will ripple, merge, and finally dissolve, erasing the last clear boundary between our two galaxies long before their cores ever meet. For now, this faint frontier remains a whisper at the edge of detectability, a reminder that galaxies aren't isolated islands but dynamic structures, constantly exchanging matter and energy with the universe around them. It's a testament to the unseen forces shaping cosmic evolution, where even the emptiest reaches of space bear witness to the grand, unending ballet of gravity. Deep in the halo's shadowy reaches, astronomers have stumbled upon an anomaly so baffling it defies every label, a flicker in the data that shouldn't exist. Dubbed the Halo anomaly, this enigma first announced itself not as a visible object, but as a brief, unaccountable distortion in the light of a distant star. For a fraction of a second, the star's brightness dipped, not the smooth curve of a planet passing in front, nor the telltale wobble of a binary companion, but a sharp, asymmetrical flicker, as if something unseen had taken a precise, deliberate bite out of the starlight. Then, just as suddenly, the anomaly vanished, leaving behind a trail of questions and a single, haunting possibility. We might have detected something entirely new lurking in Andromeda's halo. What makes this event so puzzling is the signature it left behind. Most microlensing events where a foreground object's gravity magnifies a background star's light follow predictable patterns based on the mass and motion of the lens. But the halo anomaly's light curve was wrong. It didn't match the profile of a wandering planet, a dead star, or even a rogue black hole. The distortion was too abrupt, too clean, as if the lensing object were impossibly dense yet vanishingly small, an exotic speck of matter with gravity disproportionate to its size. Some researchers whisper about theoretical relics like strange quark nuggets, ultra-dense remnants of the early universe that could, in theory, drift undetected through galactic halos. Others suggest even wilder ideas, cosmic strings, primordial black holes, or structures born from dimensions beyond our own. The plot thickens when you consider where the anomaly appeared. Unlike most lensing events, which cluster near the crowded galactic disk, this one erupted in the halo's near empty outskirts, a region where stray objects should be rare. Follow-up surveys scoured the area for any trace of a lens, a dim brown dwarf, a neutron star, even a rogue planet the size of Jupiter. They found nothing. The anomaly's source remains invisible, a ghost that bent light without revealing itself. And here's the kicker: attempts to catch a repeat event have failed. Whatever caused that flicker, it isn't behaving like ordinary matter. It's as if the halo itself reached out, warped space-time for a moment, then retreated into darkness. Could this be a flaw in the data? Possibly, but the signal was picked up by multiple telescopes, ruling out instrument error or cosmic ray interference. That leaves two options: either we're witnessing an unprecedented astrophysical phenomenon, or we've brushed against the edges of physics we don't yet understand. Some astronomers are racing to model alternative explanations. Perhaps a dense clump of dark matter briefly passed through the line of sight, its concentrated gravity acting like a magnifying glass from hell. Others wonder if we're seeing the echo of a quantum fluctuation in spacetime itself, a glitch in the cosmic code. One thing's certain: the halo anomaly isn't playing by the rules. Every time we think we've mapped the limits of what's possible, the universe tosses another curveball, and this one might be the strangest yet. So what do you think it could be? A failed black hole, a crack in reality, or something no one's even imagined? The halo keeps its secrets close, but with every odd flicker and phantom signal, we get one step closer to uncovering them. From dark matter clumps bending the fabric of space to rogue black holes drifting unseen, From primordial gas clouds untouched by time to hypervelocity stars fleeing the galaxy at unimaginable speeds, Andromeda's halo isn't just a relic of cosmic history. It's a living, evolving frontier packed with 30 of the strangest objects ever discovered. Each one shatters expectations, proving that galactic halos aren't the quiet graveyards we once imagined. They're dynamic, violent, and teeming with mysteries that force us to rewrite the rules of astrophysics. Take the orphaned planetary nebula, a ghostly bubble drifting far from its parent star, or the ultradiffuse galaxy clinging to existence with hardly any dark matter. Consider the gamma-ray bubbles towering over Andromeda like ancient monuments, or the zombie white dwarf that survived multiple supernovae. These aren't just oddities, they're cosmic keys, unlocking secrets about how galaxies grow, collide, and recycle their material over billions of years. Every discovery peels back another layer, revealing halos as the ultimate archives of a galaxy's turbulent past. But the biggest revelation, we've only scratched the surface. For every object we've catalogued, there are likely dozens more hiding in the darkness, waiting to append our theories. The Andromeda Halo is a reminder that the universe thrives on chaos, defying our neat classifications at every turn. So, which of these 30 mysteries fascinates you the most? Is it the phantom dark matter galaxy, the colliding gas cloud, or the repeating radio burst with no explanation? Drop your thoughts in the comments. We'd love to hear which cosmic enigma captures your imagination. And if you're hungry for more deep space discoveries, don't forget to like, subscribe, and hit the notification bell. The universe is full of surprises, and we're just getting started.